Hey, what's up guys? My name is Cherno and welcome to another episode of Game Programming. So today we're going to continue off from where we left off last week. If you guys missed that episode, then go back and watch it. You're going to need to. We're going to basically be talking about how the server is actually going to deal with clients and how clients can connect to the server. So that's obviously kind of a big deal that we need to deal with. And like there are many different ways of actually having a server handle its clients. We're going to talk about one of them and we're going to implement some kind of system in which that will work. Okay, so first of all, if we go into our game class, we'll see the kind of the main area of connection. So we have our to-do here that says we should connect to the server, and we are kind of connecting to the server. But remember, if we look at what we're actually doing in the client.connect section here, what we're actually doing is we're translating the address that we've specified into an actual INET address object. We're creating a socket, and then we're in our send connection packet, we're just sending this connection packet, right? We're not actually caring about whether or not it gets received or anything like that. All we're doing literally is we're sending a packet that just says, I am connecting, right? I mean, like we're literally sending these bytes to the server, and the server will, I mean, ideal, like literally just like receive it, I think, and print it, right? So processes a database, dump packet. So it will just print that it received a packet with our contents, and that's it, right? There's no kind of interconnection going on. It's just printing what it gets, which in this case is the words, connection packet. And that's it. And then we're assuming that the connection is successful and we're sending a database. So what we're actually going to do is we have connect, which of course returns a Boolean. So we're going to basically, first of all, handle the case of we didn't connect, right? And the way that this is really going to work, and we're actually not going to do it this way, and we'll see why in a minute. But this is like the rough idea of where we'll kind of start off from. So what we'll do on the send connection packet is we have to decide some kind of packet that we want to send. That is basically going to actually, send a connection packet. Like what is a connection packet, right? Eventually you might find that it might be a good idea to send the username and password as the connection packet, right? And again, if you if you're serious about security, you might want to hash the password first. If you have a database on the server, which contains, or the server has access to a database, which contains every user in it, then of course you would be storing passwords in the database hashed, not plain text, I hope. And so of course that way you could of course just use the client to take in the user's password, hash the password there and then locally, and then send a packet which has username and a hashed password to the server. Then the server can query the database and make sure that that user exists and the password is indeed correct. Okay, that would be an ideal, fairly secure way of actually logging in a user. And then the server can of course reply being like, no, the password isn't correct, or no, that user doesn't exist, or whatever kind of status you want to reply with, or maybe, everything's successful, the user is now logged in. And then that way we have basically established a connection. Now we don't have any of that yet. In the future, again, it might be something that we do, adding users and usernames and passwords and stuff like that. But right now we don't have the UI for it. And of course, I don't really want to spend time setting up UI for that now or anything like that. So we're going to skip that step entirely. Instead, what we're going to do is just send our intent to connect over to the server, and that's going to be it, right? So we're literally going to be like, I'm connecting. We might send the person's, I don't even know if we're taking in a name. See, that's another problem, right? We're not taking in any kind of username or player name. Everything's kind of nameless right now, and we're going to kind of keep it that way for now. Just to keep things real simple, because I want to lay down this framework I want to make it as simple as possible, and then we'll start extending each kind of feature. So it's almost like if we had like a little tree that we were growing, right? We want to first kind of set up, and it was like a binary tree or something, so it was limited in how many nodes each, or how many children each node can have. We're kind of setting up the root kind of first, and then from then we'll start expanding each node and start kind of, So, I mean, if you really want a computer science explanation for what I'm trying to say, you would say that I'm kind of trying to do this development at breadth first rather than depth first. So instead of fully completing one feature, then moving on to the next one, I'm kind of touching on each feature and we're going to kind of revisit them constantly. That way, I think it'll keep things a bit more interesting. And also, I mean, I like to have my entire game working badly first rather than having a little section of my game working perfectly. Okay, and I'm sure everyone's like that as well. Who wants to work on the same feature when the rest of the game isn't ready? So you have to kind of keep working on that. So that's what we'll do. So connection packet, that's probably not going to fly. We're going to basically just make a private final byte thing here that, and I don't even know, like, I honestly, again, someone's going to have to, in fact, if someone could look this up and do the research for me and just put it in the comments. Final static, like, I'm assuming we need both of them, but again, if something's final, then it's obviously going to be static in the sense that it's clearly going to be the same for each class. Like if you mark something as like const or static essentially in C++, what you'll do is like the memory which it gets allocated for will kind of be part of the executable itself. So if I make a constant kind of byte, or a constant char array or something in C++, then that string that I put in there, or the data I put in there, is actually going to be physically in the executable. Again, this is Java. I have no idea how it works, unfortunately. So if someone knows, if final static is needed or just final, like I'm basically just saying this is a hard constant that is going to be the same. Like, I mean, I would have thought the final would kind of implicitly make it static in a way, because you can't change it. So why would it be? Obviously it's going to be the same across all instances. Or does making it final mean that every client has its own memory to hold this? I don't know. I've never actually thought about it that hard, and we probably don't need to, but this is just something that I came up with on the spot right now, and I was like, I wonder if that makes any sense. Because I think in C# you can't mark something as final and static, or something, or like constant static. I'm not sure. Anyway, this is going to be so we'll have a bunch of these. So s underscore just means, am I going to switch to my convention? Probably not. Let's just make it, so packet type connect or something. And we'll just, I mean, this is a byte array. We'll probably we could send 1 byte. We could send, here's what we'll do. We'll send 1 byte for this, and this is just going to be 0, 1. Okay, we'll have another one though that is actually a header, which is just like going to be 2 bytes probably, that just kind of says, hey, this is a packet from me. And for that, of course, we might just pick something like 80, 40. I don't know. Again, I'm just 2 random numbers. Well, let's not do that. 2 random numbers. And that's more than a byte, of course. So maybe we'll do like, let's do something that we can actually read. No, let's just do like 40 and in hexadecimal, and like maybe like 4020, 420. Let's not do that. Let's do 4040. Okay, doesn't actually matter what this is. This is just something that we can use to verify that we're not being fed malicious packets. Obviously, again, it's not particularly secure because anyone could decompile our code or binary, even if it was C++ or whatever, and be like, oh look, they're sending these 2 bytes at the front of every packet. But it's just something that we're doing just to kind of have a more uniformly formed packet, if that makes any sense. And also that way we know that this is like the beginning of a new packet and not like, in case our data gets corrupted. Anyway, again, we might change that. I don't really care what it's set to. It doesn't matter. All right. So send connection packet. So we're going to basically we're going to construct our data. It's not going to be connection packet. It's going to first of all be, I guess, our packet header. I don't actually know how we're going to write our byte arrays. I don't know if we have a class that can deal with that immediately anyway. So list probably could in a sense. I don't know if Java has this, so I'm just going to make my own because it's probably useful for you guys anyway. Under util, I'm just going to make a class called binary writer. This is going to be very similar to C#'s binary writer class if you guys have ever used that. Basically what this is going to be is an underlying list of bytes, which is going to be our buffer. It's going to have potentially a constructor which takes in a size, a constructor that, again, I would make this a default parameter, but you can't with Java, so I have to make 2 constructors here. So this does nothing. This will basically instantiate the list to be, in fact, we might in that case do this instead. You import that list. So I'm going quite fast here because I didn't plan on actually doing this and time is running out. But we'll have this byte and I think we can reserve a size, right? Yes, so initial capacity will be size, okay? So we have a list of bytes here. We're going to have a, probably can't do that because this is freaking Java. Oh, okay, it doesn't matter. We'll have to set this up probably. We'll have write, okay? What write will do is basically just do, you know, buffer.add data. This is basically very similar to how our serialization handles this, except this way it's just kind of, we don't need to supply the byte buffer with a preset size. This is like a dynamically growing thing here. So for this, we'll do, we'll just make a for loop. We'll keep it simple. I mean, I'm sure we could use system.array copy or something crazy, but I am not feeling too confident with Java's API right now. And also, this is probably going to make sense for more of you. We'll, you know, I mean, we could spend all day on this really, but it's going to do the same thing every freaking time. I don't know if, oh, well, actually not every time, because we have to convert that to an, what was that magical thing I used last time to convert an int to like a byte array or a, yeah, something like that. I don't know, I'm gonna have to Google it real quick. I think there was something really simple. I know there's bit converter in C#, but oh, of course, there's this ridiculous thing. Yeah, okay, we'll just do that, I guess. Oh, Java. Sometimes I hate you. Okay, so byte. So let's do byte B for buffer, I don't know. So it's going to be byte buffer.allocate for, oh, this is such a waste of memory and stuff. Such a waste of CPU time, unless it's doing something magically optimized. And then we're going to, of course, just hit up write with that. Okay, so you guys get the idea. This is what this class is going to be. And then finally, the most important thing, I guess, is the get buffer method, which is basically just going to return this buffer of ours as an array. So to array, I believe is correct. So there's one of these doesn't work properly, I swear. So I'm just going to quickly, yeah, I mean, we might actually have to do this. I really hope not. But let's just assume that this works. Okay, I'm not sure. Okay, so it's already like, you know, not being happy about that. Maybe we can do that. See, like, why? You can't cast arrays, can you, in Java? Why not? So we might have to do, what's the point then? We might have to do byte, I really hope this works, result, to array result, return result. So does this, are you kidding me? So it actually thinks the primitive is not correct, but they're the same thing though, aren't they? Incredible. Incredible. Oh, Java. Okay, here we go. So, unbelievable. So you actually have to iterate through it? Are you kidding me? Sorry, I'm just going to share with you guys what I'm reading here from my quick Google searching. That's not, I don't care about that. So you actually have to, like, are you actually kidding me? This is ridiculous. So I guess they are different. Wow. Wow. This is great. So what we'll do then, I guess, is we'll just say, that's awful. Okay, so byte result. I really hope this one, by the way, what does this do actually? What? list, array list. So we need to get to the array list class and we need to see what it does, because I think that one of these does the incorrect thing, or at least does this allocate a new array, or do we have to give it one that's already allocated? That's so array copy of blah, blah, blah. What's the array? So A is the thing. If A.length is less than size, then make a new array of A's. So maybe it will, because if the length, I guess, oh, well, that's kind of null pointer exception actually. So it looks like we do actually have to give it an array that is the right size. This would all be solved if we could just store, you know, bytes like this, but of course we can't, because I don't know why, for whatever reason. Okay, I'm not gonna get frustrated with Java today. This is a happy episode. Maybe I'm Java-ing wrong. So if you guys have a better way of doing this, please post like a link to like a haste bin page or something. Because I actually can't believe that this is what people are supposed to do. Get size, let's just size. So to array, we make another byte. So this is just a lovely feast of allocations going on right here. Then we copy everything, which I guess I'll just do using a for loop. And I guess we can just do that, or do we actually need to like, yeah, so we can do that because they are equal, but if they're arrays, it's all over, which doesn't make any sense because the memory should be the same. Anyway, that doesn't matter. This is our massive get buffer thing, which would have been one line of C++, but point is, we've got this now. So this is what we're gonna do. We've got data, which is basically going to be, the way that we're gonna set this up is we're gonna have our binary writer. There might be a class in Java, again, as I said, that already does that. I just felt like writing my own to show you guys what it would actually do. We don't know what the size is going to be, and we don't really care too much anyway. So we do writer.write. We pass in our packet header, and then we pass in our packet type connect thing, right? So we do writer.write packet type connect. Okay, and that's going to be it. And then what we can do is just again hit up send writer.get buffer, and that's all we need to do. As far as the connection packet goes, okay? So hopefully the server will receive this. Again, we can check really easily. If I just go to the server real quick, our dump thing right now, actually, as you can see, creates a string out of the data, which is not what we want to do at this point. What we're actually gonna do is dump the binary. The way we're gonna do that is basically go through each of the, where's our data? Data.length, we're gonna go through each byte individually. We're going to hit up system.out.println, or we'll actually do printf. And you guys will see where I'm going with this in a minute. Is that, yep, correct? Okay, good. We're gonna start off with 2 tabs. Actually, no, we're not gonna do this. Let's just refactor this a little bit. So we'll start off with, we'll do a print where we start off with 2 tabs, and then we'll do a printf, which will basically take in data. So let's see, I'm going to take in a %x, which means formatted as a hexadecimal thing. I don't know if we can tell it to actually be 2 digits though, so we can even do like 0, 1 instead of just 1, but we'll see what happens. So we'll do that, and then we'll do data I, of course. Okay, and then every time we'll do every I plus 1 mod 4, so every 4 iteration, skipping the first one, of course, every 4 bytes, maybe every 8 bytes or something, we'll make a new line. So we'll say every 8 bytes, so when that equals 0, we'll just do system.out.println \n, and then another 2 tabs, right? And then at the end of this, we'll also do a print line. Okay, that way we'll have some reasonably formatted output. I will actually add like 2 spaces in between all of these bytes as well. But now what we should be doing is printing bytes, right? So we'll quickly go back here and just format that nicely. Let's start up the server. So I'll go server, debug as. Let's just quickly write some code here that said something like, okay, let's assume that started successfully. So we'll do something like started server on port 8192. Server is listening. Okay, Again, we can probably handle some better logging later. I just wanted to set something up really quickly just to get this to work. So we'll start off with Java application. Okay, good. At least we know that's happening. We'll start up our game, which should send that connection packet. So we'll start that as a Java application. Okay, that was huge, first of all. But we'll go back to, we'll stop this. Let's see, debug. Oh, what's going on? Let's stop that. Okay, and we'll stop the server, I guess, as well. So here's what we have. We have a huge amount of data, it seems. Okay, so you can see that the packet it sent is absolutely massive. Okay, and we'll talk about that later. But also you can see that in terms of what we've received, I think one space would have been enough. But you can see that in terms of what we've received, and I could probably print 16 of these, I think, in one line. There's 40, 40, and there's 1. And the rest is just 0. Now, the reason it's so big, I'll quickly mention that now. It doesn't really matter. But honestly, the reason it's bigger, remember, is because when we create data, so that's just going from the packet. Actually, let's send. We have a max packet size, which I think we use somewhere. Yes, so yeah. So over here, when we receive the data buffer, right, and we kind of decide to socket.receive it, you can see that we receive 1024 bytes. So the rest of them are going to be empty. Now we can actually check how big it is. If we actually do something like packet.get, I think there's a proper way, because unfortunately the data is not going to be, there should be a way to see how many bytes it actually read. Unfortunately, I don't remember what that is though. So we receive a packet. Okay, here we go. Okay, get length, it seems, is the right thing. So, get length, okay? So we can do that, and if we do that, it'll be fine. So let's remove that space, as I said. Let's maybe make 16 of these in one line, and then that should be good. So we'll start that up real quickly again. So we'll do debug as Java application, debug as Java application, close the game, go back to our server, and you can see that in this case, here it is. I don't know where we got that. I'm not sure. Anyway, you can see that we received 3 bytes, which is correct. What actually is that? What are we printing after that? Oh, we're printing it as a string anyway. Okay, so let's not do that, I think. Why did we leave that in there? I wish I knew. Oh, it doesn't matter. We'll get rid of that new string thing, because that's what the @ signs are for. Okay, cool. So we're receiving the connection packet successfully, basically. So when we process it, again, we'll see we have 2 kind of ways to process stuff. We have a checking to see if a string equals RCDB, and then we'll also have one other thing, which, as I said, we have this thing. So what we'll do is else if I don't know how to do this, man. So we need to check to see if the first 2 bytes are. Look, I might just do this because I honestly don't know how to do this properly in Java. So we'll do that, and I promise you we will fix this. So then the 3rd byte will be the type. So again, if the case is 1, which I might just format as that for now, even though it is exactly the same, of course, we can say something like received connection packet. Okay, again, really quick test to run. So if we should get that, hopefully, if we just go rain server, and in fact, I might go to game and just not send that RC database because I really don't care about that. So we'll quickly debug that, that, as some people might say. Okay, cool. So there we go. So we didn't actually receive a connection packet. Wonderful. Why not? Let's go back to server and see what happened. So, why did it not like my thing? Well, that's clearly false, right? We dumped the packet. If data 0 is that is what we send. And data 1 is that. Oh, data 2, whoops. Because data 3 would have been 0 because it's empty. It's filled with zeros. So, let's do that again. debug as Java application, debug as Java application, and this time, hopefully, we would have, yeah, received connection packet. Beautiful. So what are we going to do with that connection packet? Well, I'm glad you asked, because we are quickly, since we're running out of time, we're going to quickly, I'll show you guys the main idea. I did hope to get more done this episode, but we had to write that whole binary writer thing and everything. But in our server, what we'll do is we'll have a client. Now, I don't really want to call this client because it's, maybe I'll call it server client. Just because when I search for client and stuff, even though they are in different namespaces or different packages, like I kind of, you know, I think it's better just having it maybe server client. So this is what a server client is going to have. It's going to have an address. It's going to have, and this is like roughly going to be like a POD kind of structure. Like it's going to be plain old data. Just like this is just going to be like a struct really, just filled with information we need to describe our client. I'll probably end up adding methods and functionality to it anyway. But we'll just have the basic things like address and port, and maybe like a status. Okay, which for now might just be a boolean. So maybe this is more or less an is kind of connected thing. Okay, and again, since this is going to be kind of a POD structure, I'm going to make everything public because again, it's just going to be a struct. So public server client. And I guess we can create a new client with an address and a port. And then we'll set the status true. I don't really know. We'll just do that for now. Whoops, we need to make sure we assign these puppies. Okay, so what's going to happen is when we receive a connection packet inside our server, what we'll do is the server will actually have a private list. For now, we'll refer to it as a list. We might change that data structure into something a little better, like a set maybe. That would be a lot better. Yeah, we'll probably make it a set eventually. I just don't want to deal with hashing right now, but we'll make it a set, or maybe even a. No, a set would be fine. Yeah, we'll make it a set. I mean, what's it gonna? We could optionally make it like a hash table or hash map, and then have the keys be the username, because that would be quite a fast hash instead of hashing the whole object. We might do that anyway. Yeah, well, okay. Here's what we're gonna do. We're gonna quickly set this up as a set, actually. So we'll have a set of server client called clients. We're going to make this a new, I think, hash set. Yep. And I know you don't have to write it in here, but I like writing it twice anyway, just so I know what's happening. Makes the code a little bit more readable. So clients, what's going to happen is when we actually receive a connection packet, we're going to say clients.add new server client packet.getAddress packet.getPort. Okay, like we've got our client now. And the one thing I will do is we will to-do will be to have a username. Okay, so what we'll do is we will store or at least a user ID, I think, at least for now. So we'll have something like public int user ID, which for now, again, this is going to be a bit stupid, but bear with me, it's fine, and it will work. Private static int user ID counter. Maybe some of you see where this is going. So we're basically going to assign user ID to user ID counter plus plus, which means that it will, every time it creates a new server client, it will increment that static field, meaning that we'll get a unique user ID for each client all the way up to about 2 billion, which should be enough, I think. So we'll be fine. Maybe we'll start it at 1 though, just because 0 might be like, no user ID or invalid or something weird. Okay, so there we go. We've got a user ID now. And since that is unique, what we can do is, and I think that I'm actually not even sure. Let's just quickly look up object and see what the hash code is. An int. Okay, so let's take this. Is that what I want? Why is that native? Okay, anyway, I'm assuming that I can just say public int hash code, and that'll override that, right? Nope. How do I do this? I'm assuming hash code is what it will use for sets anyway. No, it's a capital C. So you're happy with that? Okay. And then I'm just going to return, because I think it returns the memory address or something like that, or the object ID by default. But we want to, the reason I'm changing hash code is because we might want to compare, you know, two objects together, for example, or just have a, like, just because we might create a new server client object with the same user ID or something, with the same address and all of that stuff, and we don't want it to think that that's a different object because it is still the same user, of course, because we use user ID instead. So we can, again, just return a user ID as our hash code. That will be a unique value. So that's all we need to basically use our hash for, so that we can, like, that will be our hash, and then we can look up, that'll be our lookup into the set, right? So for those of you who don't know, first of all, because I don't think sets are used that often, or I don't think sets are used as often as they should. Unfortunately, a lot of people, a lot of kind of amateur programmers, I'll say, will just use a list for everything, like an array list for everything. You know, whilst that is okay and probably wouldn't have a huge performance penalty in our case because there aren't billions of, or even thousands of clients, having something like a set makes sense. So set is basically a constant time lookup because it uses a hash function to figure out where the object you're looking for actually is in memory. And of course, the only requirement for a set over a list is that every object there has to be unique, right? Obviously, because otherwise, if you have two objects with the same thing, well, you can have like a multi-set, but we won't talk about that because they're stupid. You can have a set, you know, you can't have duplicate objects because then it wouldn't know which one to get, right? So typically, if you know you're always going to have a set of unique objects, use a set, because your lookup times are going to be so much faster if you're searching for an object. If you never have to search for objects, if all you're interested in is just iterating over the list again and again and again, then maybe just use the list, right? But of course, if you need specific objects, like for example, I want to find Cherno as my client, how do I do that? Having a set is going to be way better. You can also, like, eventually we'll probably, like, we can still use, what was I saying? I mean, because again, what we're doing right now is we're hashing based on just the user ID. So that's not ideal, but it's a beginning. We'll eventually probably hash based on the name of the user. That way you can quickly create a new server client object with just a name. And then that will be kind of your way to compare and like retrieve ones that you want. So anyway, now that we've done this, if we basically go into, I will basically go up here into listen, and under process, maybe up here, I will set a breakpoint or something. Or in fact, I don't even need to. I'm just going to run the server and then the client. Close the client. Under the server, I'm going to hit pause, switch into the debug view. And then what I should see is under variables, which I see nothing. I mean, what I should see, let me just switch to the right thread, I guess. Listen thread. Oh, maybe I'll just go into the stack trace. Yeah, here we go. You can see that inside this, I should have clients. I just realized this is a set, so it's probably not gonna. We have size 1 in here. I don't know if I can actually, there it is, key server client. Okay, we can see we've got an INET address, which will be equal to, we can't really see it, but it'll, I mean, it's a set object. And then the port, of course, 57360, which is our port. Status is true, user ID is 1. Okay, so there's our object. We've successfully connected a client. The server now retains that client, meaning the server can now send, you know, a message to all clients or something like that. So we have that going on. And of course, the next step would be replying to the client and being like, hey, I've received your connection. I've added you to this list. You are now connected to the server. And that's what we're going to cover next time. If you enjoy this video, please hit the like button. If you really enjoy this video and you want access to the source code and you want to support the series, then feel free to pledge on Patreon. Just $5 a month will get you access to a private GitHub repository, which is over here, which contains every single commit, or rather every, like a commit for each episode of game programming. so that you can compare the code changes between every episode, and so that you can just download the code without having to copy it if you prefer to just kind of sit back, relax, and watch the videos without having to type along. So anyway, and of course that helps the series out and ensures that I can keep putting out these videos. All right, that's it. I'll see you guys next week. Yeah, Cherno out. Fool.